Okay, hello everyone. So today, after last week's session where we introduced routing, module 14 routing concepts, today we'll focus on IP static routing. Just a brief background, we introduced routing and we talked of two primary functions of a router, which is one, to determine the best path for uh, traffic, determine the best path to the destination for a given data packet. Number two, forwarding. So today we'll talk of the two main ways of knowing the routes. Knowing the routes, filling up the routing table, how is it filled up? How do you know routes beyond your network? How does the router know routes which are not directly connected to it? I think we introduced what a directly connected network is, what a remote network is. How does the router know those routes? And we talked of two ways, statically and dynamically. Statically, where you have to manually configure those networks, which is not ideal for large networks. Therefore, that's why we have dynamic. So as far as CCNA goes, IP static routing, we definitely have it. You need to know how to configure an IP static route, a static route. Then as far as dynamic goes, we have a number of protocols that are used. But for this CCNA, I think it's okay if you know OSPF, Open Shortest Path First. That is the only routing protocol that we are going to deal with. So starting with IP static route, just a brief background. I'm going to have two sessions. This one more theoretical than the other one where we're actually going to be configuring. So basically, we are going to cover all those things, static routes, how to configure them, the standard static route, the default, the floating. How are we going to configure those, both IPv4 and IPv6? As far as demonstration goes, I think I'm going to focus on IPv4, which will be the same as you are configuring IPv6. Right. Type of static routes. What is a static route? I already mentioned the static route is a route which is manually configured. So they are commonly implemented on a network through, let me remove this. Right. Right. Commonly implemented on a network, true even when there is a dynamic route configured. So even if you have a very large network, it makes sense that there are static routes which are configured there. For example, for your stub networks, you have to configure my static routes. For your default routes, you have to configure my static routes. For specific hosts like my servers, you have to configure my static routes because you don't have a lot of servers that can be on a given network. My DNS servers, Aqua, Alpha is probably one or two, one at a backup. They will need my host static routes. So those needs to be configured manually instead of being dynamically because can I really manually configured in case of trustworthiness here out it didn't get it the best because it was manually configured. And in terms of my ADs, my ADs, my administrative distances, my static routes an AD one, which means it's very trustworthy. So I'm just saying for my networks or my routes, that your network or you as an administrator, you want to put are perfect. Those that you trust, which can be very few, they will need to be statically configured. My type in my routes here do both IPv4 and IPv6. We have, as you can see, the standard static, the default, the floating, and the summary static. We'll be looking at the first three, the standard, which is just a standard static route, which you are going to configure. The default, basically, is a route which is used when a data packet is no matching in the network. When the router doesn't find a match for a specific data packet, then it is routed to a default static route. For a floating static route, it's sort of a backup. So let's say you have your normal network and a configured static route, a standard static route, repo functioning, or a default for that matter. Then you need a backup. When that standard static route is down, when that route is down, what happens? The network still needs to continue to function. When we talk of fault tolerance, then you have a backup. The backup runs a floating static route. We'll see how we are going to configure all those. I think they will be touched on in detail. Right, next hop options. When we talk of next hop options, basically we are talking of how you identify the next hop, how you identify the next router. The next hop, what the next hop is, in simple language, is the next router. How does the router identify what is the next router after itself? So if you are sending information from, right, let me say I have two more routers here, right, network A and network B, right? Network a device PC1 in network A. If no static routes are configured, initial configuration, if no static routes are configured, the only thing configured on the network are the interfaces. This interface and this interface, these four interfaces. If the only things configured, if the only thing configured per my routers edu are my interfaces, which we know how to do, apasari paitwa both static routing or dynamic routing, what happens is PC1 will not be able to communicate with PC2 from this side because this router, what it knows is only the directly connected networks, which are these two. Those are inoziva chete. So router rako inoziva anything to do with line A, but it doesn't know anything to do with line B because it's a remotely connected network. Now, when we talk of the next hop route, kana takuita configurations IP routing yedu, is how we identify when I'm doing my configurations on R1, I'm doing my configurations ekuti ndizive kuti kunoku kune network kunoku, right? You see my configurations actually we start with the destination network, let's say IP route. That's the command. We have the destination network, which is the IP address of LAN B. Then you have the next hop after that. The next hop, it shows you which path will data packet take to get to PCB. And the path yanotora packet kana rubva ku PC1 richasvika apo kana rakubuda murouter 1 richabuda nepanapa. Let's say that is a G00 interface. Richapfuura neapo. Right. Parichapinda napo rakupinda murouter number 2. This is router number 2. Is this interface rino? Let's say interface iro IP address yepo is 192. Right. Let me write it somewhere here. Where can I write this one? Okay, right here. 192.168.1.2. That's the IP address of this interface. Right. So when you talk of the next hop, when you talk of next hop options, and when you talk of the next hop route, it means we have only the next hop IP address being specified. When we talk of the next hop IP address, we are talking of the next router IP address. So the next router, if I'm sending from PC1, the next router is this PC, router number 2 is this router number 2. And its IP address is this one. So in the command ratinoisa rekucommand router redu kuti rizive route, if I specify the next hop route only, which is the IP address of R2 in this case, then inonzi a next hop route, right? When I configure using only the router exit interface specified, we call it a directly connected static route. I'm using the exit interface. Exit interface in this case is G00. So if I'm sending from PC1, the exit interface is this. The next hop IP is the next router, the IP address iripo. When I use both, sometimes it's necessary to use both this G00 and the IP address 192.168.1.2. Sometimes it's necessary to use those two both. I'll give an example of where it is necessary. Where it is necessary, it is called a fully specified static route. So these are just ways of identifying the next hop. So you can either use the IP address of the next router, which is called the next hop route. You can use the exit interface, which is called the directly connected static route, or you can use both, which is a fully specified. Right. Where is it necessary to use a fully specified? Let me give an example. Sometimes, let's give example of IPv6. When we are using IPv6, I think that's the easiest one to understand how a fully specified static route works. Right. With IPv6, we have what we call link local addresses. Link local addresses, which are only unique for a given network. So it means, for example, router rangu R1, here we have R2. If I have another network panel, right, it went, let's say LAN C, this is LAN B, this is LAN A. If I have another network panel, it runs LAN C. I want to configure an IPv6 static route on R1, right? Panapa, the gateway, which is the link local address of this interface, is FE81. Panapa C is also, it can also be FE81 because the link local address is only unique in its network, right? It's not globally routable, only unique it's in its own network. It also means Panapa can also have FE80, right? One. It also means ndikatengwe network in a router irikuenda Panapa, it can also be FE81. Now, kana ndauda kuconfigure a route rangu, I want to use the next hop. If I use the next hop route option only, it means I'll configure R1 ndoisa FE80 :1 as my next hop route. But the problem ndeyekuti router will not know kuti inoshandisa FE80 ipi because pane FE80 irikuya panapa. This is the next hop. Pane FE80 irikuya panapa. Ndikatemwa network inouya panapa ine FE80 as well. So in that case, it is necessary to use a fully specified static route so that you can specify as well the exit interface. If I specify now the exit interface, this is G00 ne FE80 :1, it becomes more clearer. The route, yeah, more clearer than Isiri fully specified. Right. So this is just an example of why we have more fully specified addresses. And it's very important to understand the difference between all those. But kana fully specified zvichigozha kunzwisisa, it's just easier to know networks akawanda, Ethernet LAN, Ethernet networks especially, you need to use the next hop route, right? The next hop route is recommended to use. You cannot use directly connected only. At the exit interface, if you have a multi-access network, when we talk of multi-access network, a network in a shared medium and all, you cannot use a directly connected static route because exit interface inobhaisa. Unogona kubuda nepa G00, but pauri kusvikira pane manetworks akawanda, pane network A, network B, network C. So it's very difficult now for router rako to direct data traffic kupath yakanyatsoti. So it's much easier to use these, which are the IP addresses, Zema next hop routers. Right. A lot to say here. Next hop options done. Number 6, configuration. How do you configure a static route? So the basic command, this is the command IP route. Let me see. All right. So this is the command IP route. Then after that, you have the network address and its subnet mask, which is the destination network address. Which network do you want your router to know? Ndo network address irapai. So for example, ngatiri kupapa tumalan edu. If I'm on R1, then this is LAN B, this is LAN A, this is R2. If I'm configuring my routes angle on R1, what networks do R1 need to know? R1 needs to know network E in LAN B. ndoinoiswa destination network iri panapa, right? So destination network inetwork ipi inofanira kuzivikanwa nerouter isingazivikanwa nerouter, ndiyo yaunoisa apa, the network address, right? Then we have the exit interface. What is the exit interface, right? We talked of my next hop options here. If we use the exit interface, it's directly connected. If we use the exit interface, it's directly connected. If we use the IP address, is the next hop route. Eh, what's happening? Just a minute. Let me figure out why my pen is no longer working. Okay. Okay, voila, back. So I was saying if we are using the exit interface, if I'm using this is the exit interface. I'm configuring on R1. Then I'm using the directly hop option, directly connected hop option. If I'm using this IP address, I'm using the next hop route option. If I'm using both, if I use these two at the same time, I'm using a fully specified route option. The same with IPv6. Very simple to understand that command. All right, number 7, dual-stack topology. Here, we're going to look at a network. I think it's the typical network which we are going to configure. So to configure network, I get exactly like this one, where we have 3 routers. When we talk of dual-stack, we are talking of a network in both IPv4 and IPv6. IPv6, that is dual-stack, right? So we're going to configure this network, but I think from our configurations here, we're going to focus only on IPv4. IPv6 configuration is the same, right? So what we are going to look at, we're going to look at my networks. We have my networks, network A, network B, network C. If I look at R1, I'm going to identify my networks asingazivikanwa ne-R1 and the app. A inozivikanwa ne-R1 because it's directly connected. This one, another network D irapai, right? Inozivikanwa ne-R1 because it's directly connected, but R1 doesn't know this network E irapai. This is a network E, it doesn't know. So R1 doesn't know E, R1 doesn't know B, okay. R1 doesn't know C. So we are going to configure my static routes so that R1, any device in network A can be able to communicate with B and C. Tikango configure pasinaitwa static routing or any form of routing iri papo, you see that these two networks cannot be able to communicate. A and B cannot communicate, C and B cannot communicate, because hapana marauta haasi kuziva manetworks beyond itself. Right. Let's look at static routing tables. Right. So when you are going to do my configurations, this is going to be a typical static routing table. What's important to notice, panapa, right? R1 can ping R2, but cannot ping R3, right? I already mentioned this. R1 here, panap, this is our R1. It can ping this one, this interface wrapper, right? Because it's directly connected, right? But it cannot ping interface panapa R3 because haritozive kuti kune network iyoyo. And basically, that was what we are going to demonstrate from our configurations aid. Let me skip past through this. The starting routing table, we are going to show my routing tables. Initially, it started my configurations, and I want you to take note of understanding what these C's, what these L's mean. When you talk of C, that is a directly connected network. When you talk of L, that is an interface reconfigured per router. Probably the default gateway, right? I'll explain that part later, configurations a little bit further, right? IP static routes, right? This is an example, typical example of a configuration in Oshandisqua, the next hop route, right? Per command yedu, you can see we have the destination network. This is the destination network. Then what is this? This is the IP address of the next router. So these are my configurations that are pa R1. Ndikadzoka pa diagram redu, ndichida kuona what is happening pa R1. Right, let me look at this diagram. Right, if I want to configure a route pa R1 using the next hop route option, right? So I want to configure network. Let's start with, okay, this network. Today zero network E, you know, is 172.16.10. Command yangu is IP route. Network yangu 0.172.16.10/24, that is 255.255.255.0. How will I know that network? Using the next hop route option, meaning the IP address of the next router at Rugend. And what is the IP address up? This network is 172.16.2 dot, I can see a 2 here. That's the configuration in up, basically. And you could do the same for all my networks also with Ziva. So basically in Tandatombo mention, we have, I think, network A, B, C, and E. That's why you probably have 3 my routes are configured. Right? Then after configuration, we're going to verify my routes at a configure. As you can see from this diagram, 3 my routes are added. I got S at the beginning, showing that my static routes are configured. Right? And static routes pane network iripo, then pane the next hop IP address. All right, first track. This is for version 6. We won't look at this, but the explanations remain the same. Directly connected, version 4. When we talk of directly connected, what changes? This is the only thing that changes. Instead of having the IP address of the next router, we have the interface, the exit interface per router at configure. What is the exit interface? So ndikadzoka pa diagram rangu, what is the exit interface? Interface iri pa router 1 ndo rinoshandiswa pa directly connected route. That is the exit interface, which is the same as this one which is being used here. Right, 2 ways that are configure. One, your next hop, another one here directly connected. If I'm having another one, this is 3 fully specified. You can see from the command, we both have, right, we have here Giga Ethernet 001, meaning the exit interface is configured. Then we have the IP address of the next router as well configured. And that is a fully specified static route. Fast forward, let me move so that it basic configuration, right? If the IPv6 static route uses an IPv6 link local address as the next hop address, use a fully specified static route. I think I already explained this one. That's the example yema link local addresses. Right, excuse me. A little bit more panap. I've just thought of something. Right. So can I go IPv6? Starting with IPv4. Can I go IPv4? Can I do the next hop? Next. Can I do the next hop route? I just look at the router and traffic after run through configure. I find its IPv4 address. That's it. Not very complicated. When I go to IPv6, it becomes a bit different, not complicated, but different in the sense you go to now for IPv6, for same interface, I have the GUA address, here IPv6, I also have the link local, for same interface here, right? So, can I do the next hop route? I can use the GUA, which is very easy because the GUA is unique in the network. So ndikashandisa in this example pane GUA iri panapa, pane link local, pane GUA, pane link local. Ndikada configure pa R1, ndikashandisa GUA, it means I can use this address. It's not a problem. There is no need to go fully specified because this network iri apa is probably unique in the space, yes, in the environment in the networks ako, yes, right? But it's a different case kana udoshandisa address iri apa kudirecta traffic. because address link local, we can have another router panapa in the same link local irapa. So router R1, it will be very difficult for it to identify the path yangu and the IP. Basically, I think that's the best explanation why patches are fully specified. But you will see, this is all theory. When we go to practice, my fully specified, they are rarely used. My routers, my modern routers, they rarely use my fully specified. They use mostly the next hop route option instead of fully specified. Right. Verify a static route. Show commands. Very important. I have to repeat. Learning to use my show commands are very important. It shows you network marble. So these are the show commands that we are going to be using. Show IP route. In a route chete in order to complete routing table here, do I say. In a IP route static, it shows us my static routes are configured pa uipedu. I'm sure tikachinja connected here, show my routes per table yedu are directly connected, etc. etc. Right. So show IP route network shows you the specific network NEMA routes which can be identified that leads to this specific network. Right. Moving. Configure IP default static routes. Right. We talked of the default static route. Parinoshandiswa example ndipo pano. Traffic rimulani muno ikashaya match, instead of being dropped 10 minutes, instead of being dropped yashaya match, instead of being dropped inoendeswa kunonzi gateway of last resort. The gateway of last resort ndo rinonzi default static route. So we configure a route 000 for traffic inenge yashaya mapackets anenge ari kumecha. Right, and it is configured kuti riende kupi, to the internet mostly. Rinofanira to the internet. Right, how do you configure that? These are the commands. IP route 0000. Then we have the exit interface or the next hop IP address. And in this case, if I'm configuring for R1, this is the next hop IP address. This is the exit interface. So I just have 000 and I put the IP address in Panapai. IP address the interface E. Don't inside this command. IP route. And that is our default static route. Not very simple. Right? Moving to configuration. Okay, this is a typical configuration static route for the network Ngatapa. We'll do my configurations later. What else do we have? Verifying a default static route. Okay, so show IP route yako. Voila, we have the gateway of last resort. Gateway of last resort. Ndo rinokushowa kuti pane default static route rakonfigwa parouter rako. We're going to show that as well, I think. Right, IPv6, same thing. Here we have configuring a floating static route. Right, ndataura nezvefloating ndikataura it's just a backup. How does it become a backup? It's very simple. Route rako rikakonfigwa static route, for example, AD is equal to 1. That's a static route. AD, yes, static route is equal to 1. Wakonfigure default static route rako, AD is equal to 1. Kana unoita backup, unongoconfigure the same route irororo. Zvese 000 neexit interface yayo zvese zvakafanana, but oedera AD oisa possibly is equal to 5. What does this mean? Root iri rikaita down iri ndo rinosumuka iri kana riri kushanda iri AD iri lowest ndo inochuzwa, zvinoti route iri ndo rinochuzwa over this one. And basically that's the logic behind my floating static routes. Let's see pakakonfigure. Voila. Right, here we have a default static route rakakonfigure harina AD harina anything. Here we have the float rakakonfigure after. So link rekutanga irikadhakwa iri, this one rinovha raita up because ndo rine best administrative distance, which is the lowest. Right? And testing for floating static routes. How do we test for those? Tinongodhakisa link 1 toona kuti communication inoramba iripo here. we're going to do that from our configurations. Configure static host routes. Right. Tinoti my host routes. If you look at my networks, anga to configure so far, my routes anga to configure so far, to direct traffic to a specific, right? To direct traffic to a specific network. My routes atanga tichita ese. We have my networks, this one, this one, this one, network A, then we had network B. And per IP route yedu, per configuration, tanti IP route, toto what is the destination network here B kuno? Toto 192.168.1.0/24. That's the destination network. Then if R1 wants to know this network, it has to know through probably this or this exit interface. Let's use this. So we have G00, our exit interface, IP route, configuration done. We were focusing on knowing the networks. You can also do the same for my host. If we have a specific host, especially my servers. Specific host, we want to configure a path, a route to this server here. Ndoyapanapa IP route, server redo, let's say, is 192.168.1.10. This is no longer a network. And what will be the mask? Mask, is going to 255, 255, 255, 255. Door knows a host route e. You just take the IP address of the device, then the network in is /32. 255, 255, 255, 255, 255. So instead of advertising a network, you are advertising a specific device in that network. Right. Why to mention a server? Server, let me say, how do I put this? Server rene information in important yatikuda or yatida kuendesa ikoko. So instead of having a path rinotanga rasvika network, then network ezotanga kuidentify kuti server riri papi, we have a path rinoenda directly to the server. Instead yekudivheta uchienda kunetwork odi directly to the server. That's why we have my host routes. Right? Configuration. Right, we have automatically configured, automatically installed host routes. Rangantukutaurera is automatically configured. Right, for automatically configured, do atinaopa if I have a router. Okay. My pen is off. Right. If I have a router, the moment I configure these IP addresses, do anobuda nanasi my networks are up. Let's say network 192.168.1.0, 192.168.2.0. My networks anenge akanzi C routing table yedu ndo my networks 2 are up. Right? Then my interface anenge akanzi L, my IP address anenge ari panapa 192.168.1.1. Here is 192.168.2.1. My IP address ndo anenge akanzi L. So this one is L, this one is L. Iwo ari 2 aya ndo anonzi ma automatically installed host routes, because the moment you configure interface, unongotoita automatic configuration ye host route, because this is a host irrapid, it's not a network interface. You can take it as a host. So if we have let's say traffic which is destined for the interface, sometimes you have traffic which is destined only for this interface instead of being destined to the network. Inosvikira directly to the interface because of iripo routing table yakanzi L. It's a host route iripo already. It's different from the directly connected network. This is an interface. This is an interface. This is a network. Right. So when you talk of host routes, this interface is a host route. which is directly installed paunoisa configurations ako ekutanga, right? Moving static host routes. Static host route ndo randabva kuexplaina, randataura kuti pane server unoisa IP address woisa /32 which is 255.255.255, right? When we talk of configurations, how do you configure that? You can see panapa tine IP address yeserver yedu, tine mask yedu /32, then we have the next hop IP address. The configuration, the syntax remains the same, right? Going to verifying, how do we verify that? Show IP route, you can see static rakaiswa panapa iri ndo rine host route yedu. Esa aya manetworks aya, this is a network. You can see iri na iri, this is not a network iri. And rina /32 as well, showing kuti host route. /32 uyu ndiye anoshow kuti host route uyu, right? Let's move so that I finish. Version 6 yangofanana neversion 4 pama host routes. 1 minute, new terms, done. So basically that is the theory yema static routes. And if I want to summarize everything zvataita apa, it is summarized by my commands ari panapa, right? Knowing what is the command rekuisa static IP route. Zviri mukati zvinosiyana nekuti type ipi, i-default here kana kuti i-floating, etc, etc. Done. Join me after this lesson is done.